Okay, so good morning, everybody. So I am very happy to welcome you to present to you this test bench. So this is the electric machine test bench designed in the framework of collaboration or the chair between RENAULT Group and Centrale Nantes about the improvement of electric vehicles performances. So this test bench is composed by mainly 4 parts. So here you can see the electromechanical parts, which includes first the motor can be AC or DC motor to be tested. That makes the car moving. Actually, as you can see here, we are testing the electric motor of the Zoe car, which is, as maybe you know, wound rotor synchronous motor. You have also a reductor here, which plays the role of a gearbox. And here you have the load motor emulating the electric car road. So between the load motor emulating the electric car road and the motor to be tested, making the vehicle or the car moving as we want, we have some here mechanical connections. So the second part of this test bench is composed of the power electronics, as you can see here. So inside these boxes, there is static converters. So the role of this power electronics, as we have seen in some lectures, is to provide a suitable power, mainly 3-phase voltages, as you can see here, currents, to supply the motor to be tested, making the car moving as we want, and also to supply the motor, the load motor, emulating the electric car road, as you can see here. So we have also in this test bench a measurement part. So this test bench includes sensors to measure voltages, currents of the motor to be tested. We have also torque sensor, as you can see here. And we have 2 position measurements, one allowing, which is the encoder, allowing to measure the position of the load motor, allowing to emulate the electric car road. And we have also another one, which is inside the motor to be tested. As you can see here, the motor of the Zoe car. So we have a resolver, which measures the position of the motor to be tested. We have also temperature measurement. So this measurement part is very important for control purpose and to see what the system is doing. So before going to present to you the control system command of this electromechanical system and power electronics parts, we have here also a cooling system. So the cooling system, as you can see here, we have two parts. So the first part of this cooling system is composed by two fans, as you can see here. One fan for cooling the motor to be tested, making the car moving as we want. And you have another fan here for cooling the load motor, emulating the electric car road. So there is also a cooling system for the reductor, for the gearbox. So this cooling system of a gearbox allows to cool the oil inside the gearbox. So there is a system of two pumps, as you can see here, 1 and 2, in order to, with the aspiration and the suction mechanism. So this system of the pumps will ensure the circulation or the oil circulation inside the gearbox. So this oil inside the gearbox is cooled by an oil water exchanger, as you can see here. So this water itself is cooled by an exchanger of water and air, which is located outside this area. So this is about the mechanical, electromechanical part and the power electronics of this test bench. And now I propose to you to go to the control system part of this test bench. So just to say some words about the control system command part. So the role of this control command system is to control the motor to be tested and also to generate a road profile for the load motor via the power electronics in order to make the car moving as we want when we are pushing the accelerator pedal of the electrical car. So this control system command is composed of, as you can see here, a real-time DSpace system. As you can see here, there is some electronic cards. So the role is to collect all the measurements of the test bench via the electronic cards that you can see here, and also to provide common signals in order to control the motor to be tested and the load motor. So we have also a development and safety environment of this test bench, as you can see here. So we have here the first computer, which includes MATLAB Simulink environment of this computer is to develop all the controllers, observers, softwares, and so on in order to control the motor to be tested, making the vehicle or the car moving, and to impose a profile for the load motor via the DSpace real-time system. So we have also here another computer, which is based on DSpace supervision system, mainly control desk. So the role is to display all variables of the test bench, mainly voltages, as you can see here, currents, position, speed, torque, temperature, and so on. And also there is a possibility with this supervision system based DSpace to change online the parameters of the controllers or observers designed on the MATLAB simulating environment. So here also we have another computer which includes a PLC system. So mainly a programmable logic controller ensuring the safety of the test bench. It allows also to, as you can see here, to power on, to power off, to start all the elements of this test bench remotely. Remotely, yeah. So we have to, yeah, this this main goal of this PLC system is to control the motor to be tested and all the load motor, the power electronics, all devices, all materials remotely. So maybe now for our students, E-PiCo students, so as you can see here, there is some posters of our PhD students launched in the framework of the chair, as I told you, between Renault Group and Centrale Nantes. And here mainly you have the work. So if you can see here, mainly you have the work of my previous PhD student, as you can see here, Amir Mesali, who worked on observers and control of this electric motor of Zoe car. And he designed, for example, observers to estimate the position by using only current and voltages measurements. So it's for cost issues and so on. There is also some other activities linked directly to this test bench, as you can see here. So as I told you, the first thesis was about the electric motor issues, control and observers. And here, this is the new PhD thesis of Bourjad Adrien, who is now on the second year of thesis. And he works on PWM, pulse width modulation of the power electronics that we have seen, static converters. So the improvement of the control of static converters. So he made some control of this static converters to improve the performances of the electric motor, mainly the efficiency. So, and here you have other activities. you know Yassir because you worked with him about smart charging, electric vehicle, as you can see here. So I think we had a presentation from Renault Group with Mario Alvarado Ruiz. So he presented all the activity that we have done in this thesis with Yassir. Okay. And here, so the thesis of Yassir is about supervision, so optimization of the electric vehicle charging and discharging. Okay, it's a high level work, and here we have also another PhD thesis of Hussein Al-Attar, which is launched just after the thesis of Yassir. And it is focused on the control and performances improvement of the AC-DC and DC-DC converters, so power electronics, as I said, as we have seen, for charging battery electrical vehicle charging issues. So now I will finish here my talk and this presentation. If you have any questions, any comments, so I will be happy to ask you to your questions. So Marico,
hello.
Yeah, hello.
Thank you so much, Professor, for your presentation. It was really perfect. I have a question about DSpace.
Yeah.
You were explaining that your control system is based on DSpace. I just want to know more about this. And is it an open source software? How we can know more about it? Is it possible for us to access it, to learn more about this? And it would be great if you can explain more about DSpace for us.
Yeah, so yeah, thank you for your question. So it is not an open access software, because as you know, real-time DSpace work with MathWorks, and you have you have with this DSpace real-time systems, the environment of MATLAB Simulink linked to MathWorks. So it's not an open source. So all the controllers, observers that we are developing are implemented on MATLAB Simulink linked to MathWorks company, which works strongly with DSpace real-time system. So,
okay, so
you don't have an open source, yeah.
Okay, so it is something that all the companies use for the test bench, usually? Not
all companies, but mainly, as I know, Renault Group work with this software, the DSpace real-time system. So there is other companies which are working with other software sources. So as maybe you have seen with guys from I don't remember from CMS maybe about the software
AMSIM.
AMSIM, yeah. Thank you for this, yeah. Yeah, for
AMSIM,
example,
yes.
CMS is working with AMSIM, but it's not an open source software.
Okay, thank you.
You're welcome.
Professor, I have one question.
I'd just like to know how the motor is powered. Is it via the power electronics? Because you did not mention anything about the battery powering in the test bench.
Yeah, here we don't have any battery inside this test bench. So the battery is emulated by, as you can see here, a three-phase system, which comes from a transformer, high power transformer, which supply this test bench by a three-phase system, as you can see here. And this three-phase system are connected to power electronics. So we have, of course, first transformer, which reduces the power. And this power is fit the converters, mainly AC, DC converters, in order to generate the DC bus.
Okay. Yes, thank you, Professor.
You're welcome.
Professor, I also have a question.
Yes.
Ivan, for me, it was quite interesting. While we were working on the project, we were working just with 1000 RPM from the test bench. Why are we testing with such low loads, like 5 Newton meter of torque and 1000 RPM? Is it truly powerful, the motor? For me, it seems like the motor is not that powerful.
Yeah, the powerful of the motor. You mean the powerful of this test bench, or
yes,
the motor
of the motor of the Zoe motor.
Yeah. The power of the Zoe motor here is 55 kilowatts. Okay, and there is maybe 100. So maybe less than 100 Newton meter of the torque. Okay,
but
so
it is a lot.
Yeah. So I can give you the characteristics of this Zoe car, Zoe electric motor car. So we have here 400 voltage. And we have 6.5 kilowatt, and you can deduce the current, and the torque is less than 100 Newton meter.
So thanks. Sorry, I was just clarifying because in the project we worked with the data from the test bench, and it was just 5 Newton meter, the torque, and the speed just 1000 RPM. And I started thinking, why it's so low? Now I see that it's powerful, so it allows us to reach 100. So thanks a lot for the answer.
Yeah, you're welcome.
The data that we gave to you are the data of another test bench, a small test bench.
It's
yes,
small power. Yeah, this is the another. So because here in Centrale Nantes we have another test bench with reduced power. Let's say 1.5 till 3 kilowatts.
Perfect. And now it explains everything, because when I got the data, and I was like, no, it's not that powerful for the car. Now I see.
Yeah, it's not the power for the car. This is just a reduced power. It's not real power of the car.
Okay, thanks a lot for the answer. Now it's clarified. Now everything is clarified.
Yeah, you're welcome. Have another question?
Professor, I have another question. First of all, thanks for your presentation. It's good to see real equipment that the university can use. So my question is regarding this very subject. Since we are a university and we have a test bench, do you think in the future you will be able to couple different motors from different cars to compare them, if it's maybe a subject of interest to the university?
Yeah, thank you for this question. Yeah, so first of all, it is important to know that this test bench is designed for testing more power motors of Renault, because here you have the motor of the actual Zoe car, which has, as I told you, 5 kilowatts, and the future Zoe car will have a power of 150 till 60 kilowatts. And this test bench is designed in order to test this kind of electric motor power. But we can also test another motors from another companies, if that you mean. But actually, we are working exclusively with Renault Group. So we are able only to test motors from Renault Group.
Right. If we wanted to compare different motors, we will need a different bench, right?
Yeah, we can compare, we can test here, we can test any motor till this power that I told you, 150 till 60 kilowatts. All motors that don't have more than this power can be tested in this test bench.
Right. Right. And another question, do you know if the other partner universities have a similar test bench in case we wanted to try it? I don't know if it's for you to answer. But...
So for my knowledge in this area, I think from in France and maybe in Europe, I don't know if it is the case in all the world. I didn't hear from such a test bench, let's say academic test bench with this real power till 150 or 60 kilowatts.
Mm-hmm.
In companies, they have such test bench, but in universities, academic side, I'm not sure. I am sure that in France, and maybe I'm sure in Europe, you cannot find such a test bench.
Mm-hmm.
On the world, maybe, but yeah, we have to check.
Okay, great, thank you.
You're welcome.
Malek, it's 1:35 already, and Mr. Benedetti is already online. So,
okay.
Unless you want a last question, otherwise, if it's okay for you, we'll have to switch to the Modis talk.
Yeah, I think, yeah. If there is no further questions, so we can switch to the talk of Modis.
Bonjour, Malek. Thank you for your presentation. And I have just one question about the purpose of this test bench. If it is related to the software part, so the observers and some improving of software part, or is related to the economy of the electric motor of the car?
It's more related to the software developing observers, controllers, rather than economic issues.
Okay, thank you.
You're welcome. Okay, so if there is no further questions or comments, so we can switch to the next presentation. This presentation will be given by Modis. I think Modis is connected.
Yes, I'm here. Thank you so much. Hello, everybody. Thank you. Really thank you.
You're welcome. So, yeah.
Opportunity to be here. Yeah.
Yeah. Thank you for accepting to give us a talk for our students and other people.
Oh, so of course. I'm really glad to be here.